I'd like to call the meeting, June meeting, 2025 HomeBrew Robotics Club to order. Let's get this party started. Welcome everybody from all over, including Maker Nexus and Sunnyvale in particular. This month is our challenge, one of our challenge meetings. It's actually phase 2. It's a 23rd year, no less. So this is awesome. Let's go ahead and get this started with industry news. Anybody have industry news out there they want to talk about? Robot industry. Let's see. I've got something here. I don't know if anybody saw it, but there was a Hello Robot demo. They did at some conference or something, and it was funny because it reminded me of our show and tells. They were showing Hello Robot, which is this high-end robot that's in the press. It's very interesting linear actuator and grabber and so forth. They're doing some things with LLC, large language, LLMs, large language models, and AI and stuff. But they're having the robot grasp a cup on the table, and the guy was like making gyrations and stuff, as the robot was manipulating toward it. But the robot, I think the demo was about understanding red cup on table, and it was clearly doing that. But the robot was having a hard time grasping the cup, and the guy, had to reach over and move it over, and it kind of reminded me of some of our TableBot challenge stuff. So, anyways, if anybody finds that video out there, Hello Robot, it was at some exhibition, and that's not funny because those are like $1 million demos, But anyways, it's all HomeBrew. Pardon?
Pretty good robot.
What?
What did you say?
Oh, I said it's funny for us.
Yeah, well, but it's real, and this is the live demo. You live or die by the demo, and so here we are. Any other industry news out there? I've got another one here. This is something I spotted in the wild. It's probably targeting me with the advertising, but it's the SwitchBot. This is it's really a robot vacuum cleaner. I'll share my screen. I'll actually allow share. Oh, screen sharing's on. Thank you, Thomas. Thomas is our Zoominator this evening. But this is an interesting product. It's the SwitchBot. I put the link in the chat. This is what caught my eye. This is actually being used as a tabletop. The tabletop is the end effector, where you'd have a table go here, there, wherever.
The aesthetic makes me think of a moving air filter.
Hey, sometimes that would be
I don't know if you can buy this.
How much they charge?
Okay, you can buy it now, $740.
Recording in progress.
Is the audio from the video coming through there?
No.
Yeah, the audio,
Yes.
no, the audio's not.
The audio was not coming through. That's fine. It was cheesy music, anyways. But I thought that was a pretty cool robot. SwitchBot, that was featured at CES. So, is there any other industry news out there someone wants to talk about or mention? I guess probably the best news site for robot news is the Robot Report. So I'll put a link in here for the Robot Report. And so they have a pretty good list of stuff to keep up on. There's always stuff going on. Moving right along, let's get into club news now.
Can you hear me?
Yes.
On the AI side, there were two different decisions that's pretty interesting, indicating that training LLMs, etc., is fair use in general.
Interesting.
Just not necessarily if you're using pirated content. So if you can legally get access to the content, you can legally train LLMs, etc. Pretty sure what's going to happen is that, I mean, that's probably a
Hang on a second, Stephen. Hang on a second. Back up a little bit. Is training sets? What exactly are you talking? Training sets? Is that what you're talking about?
Yeah, so basically, if you can legally get access to data, so like all the public information on the internet, you can train an LLM or other AI models on that data, and that's been ruled by two different judges as fair use.
So if somebody's posted their model to the internet and you get it that it's free, if they posted it to the internet, it's fair use. Is that what you're hearing or understanding?
I'm talking about the source material.
Is it implying that the copyright doesn't matter, or that falls into not legal?
It is.
Okay.
I was say it's implying that it's well, it'd be basically be like it's not so much an exception to copyright. It's like, is it if you can access it, it's fair use, like kind of thing, as long as you use legal channels,
Yeah.
right?
Well,
I
you
think this-
can't repeat it exactly, but you can read a news article and then write your own summary of the news, and that's perfectly fair use as a human. So,
Right.
I mean, you could argue that the LLM is doing the same thing.
Right.
But, you know, another curious thing on the LLM, YouTube fed me this. There's a content creator called Veritasium. They do, he does science stuff. And it played me a video from like 2 years ago on what makes human experts. And he was talking about chess players and people can remember 20,000 digits of pi and things like that. And there's studies on how people become those experts. And so it's like chess players, an expert chess player wins almost all the time, whereas an expert economist forecaster is almost always wrong. And what's the difference? And the summary at the end said, what things that you can become an expert on, you have to do a lot of work, many repetitive, exercises, but it also has to be the kind of thing where you get very quick feedback. So that a chess player wins and loses a game in an hour. He knows very quickly if he did something wrong as he's learning. Whereas if you're an economist, you make a prediction and 5 years later, you'll find out if you're right or wrong. It's not an effective learning cycle. But, I mean, I love these, I love the LLMs. It's amazing how good they are at many things. But it fits the same pattern. If you ask an LLM a unique question, you often get these hallucinations. But if you ask them, how to code a basic web page, well, that's been done 1 billion times. It can learn that well, So what makes an expert LLM is very similar to what makes a human LLM, just large volumes with very positive, quick feedback. It was pretty interesting. I mean, I'm the one to draw the conclusion to the LLM. This was kind of pre-Chat GPT that video came out on the human experts.
Does anyone recall, like maybe 35 years ago, IBM and other people were pushing something called expert systems? And I
Yeah.
wonder whatever happened to that.
That was the late 90s, and
Yeah.
it was a very
Well,
weak AI-ish stuff.
yeah.
It was very weak, so that's a problem.
Yeah, some of the stuff was interesting, though. I remember when IBM came out with OS2. OS2, they were trying to do things with vision where they were classifying by color and texture and shape, but that never went anywhere.
Oh, you can't say that. It's industrial. It's like OpenCV is out of that generation, which is really useful, and especially if you need a very predictable process. The part of the problem with LLMs is they're not that predictable and provable. But yeah, expert systems took too much effort to build because they used human experts.
It was essentially a bunch of if-then statements.
Yeah.
A descendant of it you might think of as a behavior tree or something like that.
What was that first chatbot that just kind of parroted your questions back to you back? Like
Eliza?
Liza, compare Liza to ChatBT or Grok,
Yeah.
I mean, it's just,
Yeah, that's not a fair. Not only is it not a fair comparison because
All
of
right, guys.
the age, but
Let's
the
continue this on
goal
the
is different.
mailing list. Let's continue this on the mailing list. Stephen Williams, spin up a post on this and put it in the mailing list, and we'll continue this discussion on the mailing list. Is there any other, where are we, industry news or club news?
Industry
I think
news.
we're
Club.
trying to move to club news. We need to get this thing rolling. Club news, Robo Magellan. Hey,
Robo Magellan.
yeah, do you
Tucker and I
have
were
video
there.
to show or something there?
I don't have video to share of that. I brought it with me.
You got it?
Yeah.
All right.
Let me share the screen here. See
And
how
this
that.
is Nathan Lewis, right?
Yes, Nathan Lewis. All right. Share. Watch everything explode. Where is the share thing? Click share. Come on. There we go. Use desktop capture. I'll use my laptop screen. Oh, hooray, it broke. Okay. Okay, well, we've lost the because Zoom minimizes itself when I share something. Okay, either way. All right. So how about I do the other window then? Okay, sorry. Stop sharing. It's gonna come back, right? Okay, hold on. I'm trying to share the TV so that so everybody can see. Everybody here can see. Hold on.
Settle down, Nathan. You're doing fine. In the meantime, I got an emergency. I don't have any power and my AC doesn't work. It's like 80 degrees in here. My computer might go out anytime.
All right, so we've got some photos, got some. All right. Oh, thanks. Thing. All right. HE Gwenview. You know what? Fine. We're gonna Google Photos. Oops. I'll play the videos locally, but albums. HBRC Robo Magellan. There we go. Okay, can we see the screen?
Yes. Oh, that's nice.
All right. So yeah, here is all of us in the park. Me testing Kubernetes. There's pictures that aren't me. Hold on. We got Marco had Entdecker out there. Also have Entdecker here as
Go
well.
Decker.
And then
And Marco touched the cone.
Marco did touch the cones. Marco
That's what I
actually
said.
run in. We can yeah, so I got Kubernetes with my Instacam. There you go, hold on. Here's the one where he hits the cone. This is Beresford Park in San Mateo. So we went up there.
Has an orange shirt. It's gonna go for him.
So this was Beresford Park in San Mateo. So it was actually a really nice location. There was public bathrooms available. The parking was good. There was some green space we could set up in. We had picnic tables. It was actually a really nice spot, and nobody came and told us we couldn't run our robots around. So that was also good.
That's awesome.
Here's
We're gonna try and do this again in
another couple of months.
September.
Kubernetes. Here's my we call it Instacam footage. So it kind of looks like you're floating behind it. Running over some children,
Careful now.
Yeah.
That kid was wearing an orange shirt.
But I'm running the cone slayer neural net, so I'm actually attempting to do cones. But yeah, and yeah, either way. and spend the whole thing on me. All right. Oh, that's going through the video, not okay. All right. Here's Survey's robot. I don't think it has a name yet, but his new feature for this is that he 3D printed this like flexible cat toy tail thing that goes on it. So yeah, so because he doesn't have a contact sensor, the way that it works is where's my mouse? Yeah, because he doesn't have a contact sensor, the way that it works is just this come on, where's my sorry, trying to find my mouse cursor here. Can't see. Right. It's not a sensor at all. But basically, he can tell that he gets close enough to the cone, and he spins in a circle. And because the cat toy is hanging off the back, it will impact the cone. So it's the yeah. Here we go. Where's how it works? Yeah, here we go. So it gets itself up and close. And so the cool thing about this robot is that the entire thing is based on his cell phone. So it does have a, yeah, there we go. That's how it works. But so and then he's got his tape measure for counterbalance, and then but the his goal is that all of the oh, hold on, okay, his goal is that all of the basically use all the sensors in a cell phone rather than using like local sensors. So since your cell phone has compass, gyroscope, it has a camera, it has a GPS, like he's just there's a Raspberry Pi that bridges the phone to motors, but other than that, it's all in his phone. And so his whole RoboMagellan like code is actually it's a website that he runs on his phone. It's a web page that he logs into on his phone, and then
Is Survey there?
Survey is not here.
Okay.
I hope he's online, or he said he wouldn't be here when we met up, but yeah, so it was, and he got all the way to the end. So where's the end here? Yeah, but yeah, and we got all the way to the end cone.
Excellent.
Yeah.
And contact. Woo! How does it feel?
Yeah, okay. So all right. And then let's see, escape. Where's the next one?
Looking for you guys do this like time over time.
Mhm.
What changed about the challenge?
What changed? So, I mean, honestly, for the most part, like there have been some people have had a lot of trouble like actually hitting the cone at some point. So it's I'm not pointing fingers, but so for a lot of people, it is eventually just getting to the cone. But so as of late, so this time all of us hit all of the cones. So we're gonna have to figure out how to make it harder because it is just the three of us. I mean, we hope more people will want to build these and come out and like hang out with us because the last two of these, it has been Survey, me, and Marco. Like all but there were a couple like I think
Quality, not quantity.
quantity, yeah, quality, not quantity. Yeah, but we are trying to encourage people to build these and come out. And because besides the robot part, it's a fun day in the park. And the weather was absolutely gorgeous. There's 3 robots. There's Decker about to knock over the final cone. Yeah, you did not knock. Yeah, you did not knock it over, but the photo is perfectly timed to make it look like you did. And we got Decker's onboard footage.
He's just pushing it,
Yeah. Yeah.
making sure it's touched.
And then we got Marco's Ardu pilot map.
Awesome.
Yeah, and then we got some PID. PID. Was it the GPS track or the? Oh, okay. Okay. This was, let me try to zoom in here a little bit. Oh, that didn't work. But if you can tell, these orange dots were our cone, or so we had our starting cone up in the top left, and then our 3 bonus cones, and then our final cone was over under this tree. And this map was shared on the mailing list. It's also in the Google. I mean, it's in the Google Photos album. Here's another Marco onboard footage. This I think has the LLM, not LLM. Wow, everything's an LLM now. No, this has the Cone Slayer output. Yeah, so there we go. A cone,
Cone Slayer.
Yeah, so there's the cone at this position relative to the robot. Yeah.
Oh, are the locations like shared before you guys?
Yeah. So we share the GPS coordinates of the cone, but like unless your GPS is 100% accurate, like you still have to figure out how to get onto it. So Marco and I are using this object classifier called Cone Slayer that's trained to, the only thing it can recognize is traffic cone and not traffic cone. The reason it exists is because somebody was competing in the Formula Student competition, and the way they designate their tracks is they line the tracks with traffic cones. So somebody had trained a model even for the camera that we're using to recognize traffic cones for that competition, which works perfectly great to recognize traffic cones in RoboMagellan. It's just a happy accident, But yeah, so there's that. I think that was the last picture. Yeah. Yeah, those are. And we got, oh yeah, there was, where's this video? Somebody, I think it was Servi, went and did this nice running after my robot to get some cool footage of it, looking like somebody's running along with it, right? Yeah. And
Very
that's
cool.
those orbit like pictures. There's the stick with a camera on it coming off the backside there. So I get my videos. Yeah. So that was RoboMagellan this weekend.
Very cool. And we'll try to do this again in September.
Yep, we'll try to do it again and align with the other challenge meeting.
I was impressed how it avoided moving obstacles like the other kids playing in the park.
You'll. I tried to. I got lucky, is what I did. I got lucky.
Very cool. Okay, so other club news. We don't have a presenter for next month. So if folks know of somebody or want to do a presentation, contact Stephen Williams. Stephen, raise your hand. And presentations is not just Stephen and my job, it's everybody's job. So do a presentation or find somebody that would make a great don't book them, ask if they're willing, and then contact Stephen and we'll get them booked. So we need a presenter next month. Our business meeting is for the first Wednesday. Our everybody knows our web page. Let me look in the chat real fast. HBRobotics.org, and basically it's first Wednesday is the business meeting. The penultimate Wednesday is the builder's SIG. That's kind of random access. Talk about robots, building robots, etc. On Tuesdays, we have a Ross discussion group, and on Thursdays, we have a voice intelligence group, and that gets posted to our mailing list. So go to our website, join our mailing list, and that's how you keep up with all the robot news and goings on of the HBRC. What I need help with is is there any other club news? All right. What I need help with, is there anything anybody needs pressing help with or got amazing help with or recently, or any comments in that category? All right, let's move on. Oh, go ahead.
I have a comment. I ran into a problem with Ross 2 camera Ross, and what I usually do is I start with a desktop image, and the desktop image does a lot of things, including things like install Snap. And what Snap does is it fixes all your UDEV rules. So I decided to have a streamed down image with less overhead, which was a server image. And the server image doesn't do UDEV rules. So I was having all these permission problems with the camera that I couldn't figure out until I finally figured out it was a permissions issue. And then I put in the right UDEV rule and the camera started working. So just a tip there.
Okay, so if you're
Also add
working
your,
with server version of Ubuntu, what enable what do you need to enable to write?
Yeah, I wasn't. It needed it needed UDEV rule to access the Raspberry Pi camera.
And the desktop install doesn't.
The desktop install, you typically do things. You install this, that, and the other thing. You install Snap. Snap typically takes care of all the UDEV rules.
Sounds good. Okay. Any other what I need help with? Thank you, Alan. All right. Let's move. Did you have something? Let's move this thing on. So this is this normally at this point we have show and tell and then we have a presentation, but this is a special month. This is our challenge month. This is our 23rd annual HBRC challenge phase 2. 23 years ago, when we were meeting at the Cupertino Library at one of the SIGs, we were lamenting the lack of building, and we observed that building coincided with contests. We had a line following contest and a maze following a maze busting contest, but there were winners and losers, and you had this equipment that you had to store and stages you had to set up, and that's when it was born. We met at a library. There were tables all around us. We started talking about tabletop soccer, and we talked about putting a net around the table to catch the robot and so forth. But, you know, that would be something that you would have to set up and lug around. And that's when it was born, the TableBot. How do you get to tabletop soccer? It was just non-trivial. You get to it with phases. And so we came up with the idea of phases. With phase 1 is just to stay on the table. Phase 2 would be to find a block and push it off the edge of the table. And phase 3 would be to push the block into a shoebox mounted at the end of the table. We didn't specify the size of the tables, the colors of the tables, the size of the robot, the block, the box. I've seen some awfully big shoeboxes in my time. But anyways, the next year we expanded it into the HBRC challenge, featuring the Floorbot challenge, which the Floorbot is a robot that's too big for the table. So it has phases also. Phase 1 of the Floorbot challenge is to go from one end of the table to the, or one end of the room to the other and back. Phase 2 is to find an object in the room, and phase 3 is to fetch that object. So we've had Floorbots do phase 1, 2, and 3. There are some other 3-phase challenges. The ArmBot challenge, the AI challenge, the line following challenge. But what I like best is the run what you brung. This is where you bring in your own special personal robot in some state of finished, you know, in phase 1. And then you've got the June and September meetings where you can expand your goal and continue to build out your robot. So without any further ado, let's get going here on our 23rd annual HBRC Challenge Phase 2. I'm going to start it off with a TableBot.
Alrighty.
So this is a TableBot. This TableBot I know does phase 2, but on a good day I might get lucky and get a phase 3. Let's see.
That Ultimate TableBot?
Pardon?
Is that Ultimate TableBot or
No, the ultimate TableBot's long gone.
long
That was
gone?
that was stamp based. That's an old Servo article. Let's do this. Let's do a phase 2. Oh, I didn't get it. We'll get him over here. Dun, dun, dun. Go get it.
Really likes the box.
This is like the Hello Robot demo.
Hey.
I'm telling you, it's all show business.
Mhm.
Let's see here. I got to get my block. All right. So here we're just going to go for a solid phase 2. Well, how about a very fluid phase 2?
It's the box.
There he is. There he is avoiding the block. Let's try it one more time. Actually, okay, this is serious. One more try, and then we'll call this one quits because I don't think you can sit through 5 minutes of this. I'm not going to subject you to that. Okay, there's that. Okay, one more try. Put the block here. There's my shoebox, and here's the robot. No, he's a quitter.
Gotta love it when they don't do what you want them to do.
All right, that's it on this one. Let's try another one. You get 5 minutes per robot. Oh no, it almost made it. That's not quite in. Try it again. Back in there. Buggy 3. The original one was buggy there. Hang on. This battery in here. Yes, I'm gonna take it. I'm not proud. All right. Are you not entertained? Hard to impress.
Easily
but easily
amused.
amused. All right.
Nice
All
thing
right, let's
is you
start
didn't
off.
do phase 4, so yay for that.
Oh, yeah, I didn't do a phase 4. Thank you
four.
for that, Dee Dee. Phase 4 is fall off the table. You can do a phase 4 where it falls off the table as long as it still runs when you put it back on. All right, let's pick this up at the Maker Nexus. Are there any table bots there by chance?
Not a table bot.
Um,
All right.
Go for it.
All right. I got a table bot. Let me see here. All right. So let me reposition this camera here. All right. Table bot. So we're gonna hope that this works. All right.
First
So
off, what's the robot's name?
this robot is called Junkbot because it is called Junkbot because it is made out of junk, which is or what are we calling it? So
Affectionately known as Junkbot.
affectionately known as Junkbot because I don't know. I was going through all of my electronics that I'm totally not hoarding. And so I decided, you know what, it would be, I know it's 2025, but why don't we build a table bot out of a basic stamp? Because why not? Let's see if we remember how painful that was. And it was quite painful. So I forgot that, it has no interrupts. So you have to not do something while waiting for data to come in from the camera and other stuff. Anyway, let's see if it works. So so it should be able to do phase 1 and phase 2. We'll take this half table here. So when you start it up, it just does the white balancing that you have to do for these old, because, oh yeah, it also has a CMU cam version 1 that I've had since I think 2002. Okay, so it started up. I have this little phase selector here. I can tell it what to do. So we're going to start with phase 1, which hopefully it will go from one end of the table to the other and not fall off. So we're going to try run. So hopefully it will go from one end to the other. It doesn't really know what direction it's pointing. It just sees an edge and then turns around. Hopefully it goes to the other end of the table. All right.
It's seeing the edge with the CMU cam?
It is not seeing the edge with the CMU cam. It is seeing the edge. So there are, for the camera, there are 4 of these old Sharp IR distance sensors, one on each corner. Kind of this thing that looks like a flower here.
I know those sensors.
Those sensors, and then there are 2 that are looking forward for obstacles. All right.
Oh,
so
that's a special 3D printed mount?
Yeah, a special 3D printed topper that I made to hold all the sensors because I don't really have space to work on wood. So we'll give me one exception for the 3D print, to use old stuff rule. All right, so I turn that off, turn that back on. We'll do the demo I did at the last meeting. So we got phase, oops, I didn't recognize the cone. I mean the edge. So, or the cube, or sorry. So we got 1, 2.
The block.
The block. All right, so that's 3. All right, so this should follow the edge of the table, presumably.
And that's using the IR.
Yeah, and that's using the IR. Yeah.
I feel
Right,
like
with a
I've
boat.
seen this robot from Fry's Electronics in that kit, the Parallax kit.
Yeah, so the Bobot, yeah, I mean, this was a Christmas gift when I was a kid. So,
Time flies.
okay,
You're still a kid, Nathan.
still a kid. I'm in my 30s now, Camp.
I get mistaken for an adult because of my age.
Yeah, the problem is, you become an adult and then something goes wrong and you're trying to find an adultier adult. Okay, so that was phase 1.5. Okay, so we'll do our proper phase 2 now, hopefully. So
That was
all right.
awesome.
Power it up and then select. I have it where you push the button and then the light blinks for what phase you're trying
Well,
to go
what
to.
did you just put in the back of it?
All right, so here are my
Okay.
objects, my
Your block.
and my blocks. And so hopefully it will keep running around and just pick up any block that it finds and then throw it off the table. That is what it hopefully does. So we'll, just to make it a little harder for me, we won't point it at the block to start with.
If it can successfully pick up that block and drop it off, it'll have done better than the Hello Robot
Okay, there we go.
in this major demo. Yes.
Yeah. And so it should just keep meandering around and find green blocks and throw them off the table. And then
That's awesome.
all right, I have other green blocks, so let's see what happens if I throw more green stuff in here.
I hate green blocks on my table.
All right.
Oh wow, the camera's actuated too. That's sweet.
Yeah, I put the camera on a servo, so it
All
idea
right.
we're doing phase 3. I want it to look up to see the other to find essentially a marker on the box, and so if I throw another one in here,
Right on.
there we go.
Wow, that's smooth.
Well, hold on. There we go. Well, so I think I may have accidentally deleted the part where it drives back because it's trying to center the object in the field of view. And then when it gets close enough, then it's like, oh, I must be basically if the camera's below a certain angle and it's centered, it says, oh, I must have the object in the right place.
What's the servo in the rear, Nathan?
The servo in the rear is to run the gripper. So it's just a parallax servo. But here, let me if I pick one of these up, point the robot the other way. So maybe you can see it actuating. So I'll put the thing there. So
yeah, I see it.
Yeah, so that runs the gripper. So there's a little tie wire that runs under the frame that connects to the gripper on the front.
That's awesome. Thank you very much.
Nope, not that one. Oh, it's gonna get stuck under it and then confused. Okay. All right. So that is my phase 2. So hopefully I was hoping to finish phase 3, but I didn't quite get it done for today.
That's a phase 2. That's a phase 2.
Oh, sorry, phase 3. I was hoping to get phase 3 done. Sorry.
Okay. All right. We got something for September.
Yep. Or next meeting, challenge meeting.
All right. Thank you very much, Nathan. Do we have another table bot at Maker Nexus by chance?
All right. My little microphone.
I think I'll stick with the narrow table also. Might as well.
I was wondering if you might be able to jump again.
I'm sorry. Is this Andrew? Who is this?
This is Anthony.
Anthony. Good to see you, Anthony.
Yeah, you too. This is my object. My son made this. It's origami.
What's your robot's name again?
This is we named it last time. We named it Slim Vision, but this is
Slim
Slim
Vision.
Vision.
Oh, that's right. You posted on the mailing list.
Yeah.
Are those like the volume dial?
Yeah.
Something for wheels.
Yeah, we've got some volume knobs or something from an old stereo. A lot of barbecue skewers, some craft tape.
That is home. That is home brewed.
Yeah, I spend as little time on the peripheral stuff, as possible.
That
The
is
most-
home brewed. I love it.
So
Popsicle stick, barbecue skewer technology.
yeah. Unfortunately, this one is just a little slow, so it's gonna. We'll
You got
see.
5 minutes.
Okay. So yeah, the idea was that it's only using the camera, and between trying to not fall off the table, find the block and push the block off, just trying to do all 3 of those things without getting stuck.
So is the phone your processor?
No, the phone right now, I'm just gonna kick off. The only thing that makes this necessary is to say, turn on autonomous mode. Yeah. In debug mode, it still sends all the same, it tells you what the commands would be, like, oh, this would be a turn to the left, or this, I see the cube or whatever, but it doesn't do any of the motor driving, right? And then as soon as you say, okay, go autonomous mode, then it will actually drive. Yeah, but all the processing is done on board. So getting the computer vision models to be small enough file size was one challenge, and then small enough the footprint when they're running, that's another challenge, and then the accuracy, having good enough accuracy is another challenge. Between all those three,
What's your compute?
it's a ESP32, which I don't know the actual amount of RAM. So far, it's not my best demo.
This is the same, or what have you changed since what is that? Because I think I remember seeing this in March, right?
Yeah, so the first time around, it was only running like 2 or 3 really simple classifiers that were looking at the geometry of the tabletop and just trying to figure out where edges were and avoid them. And then this time around, it adds a actual like object detection model that spots that thing and tells you where in the frame it is, which allows me to correct the heading. And then and kind of know how far away it is, but that's iffy.
What AI are you using, Anthony?
So the models are all done in TensorFlow, which is just kind of the first thing that I started experimenting with. See, I should have made it just run automatically, when you power it on, it should just go. That's what I get for building in a soft switch.
Trying to connect to your home Wi-Fi first, or
no, it's got its own access point, and I connect to it, and I say, okay. Disappointing.
Are we having technical difficulties?
Yeah, more than a little bit.
All right, we can come back to you.
It's not showing up.
Yeah, it's just not. The page is not coming up. I don't know if it's
All right.
overwhelmed.
Narrow views not cooperating this evening.
Somebody else wants to go.
Narrow vision. Is it narrow vision?
Slim vision.
Slim vision, same thing.
Slim vision. Yeah, I'll come back on if I get it to work.
All right. Very good, Anthony. All right. Is there another table bot at Maker Nexus by chance? Going once, going twice. Is there a table bot out in Zoom land? Table bot challenge. Going once, going twice. Let's move into floor bot challenge. Does anybody have a floor bot that they want to demo? I have a floor bot I'd like to demo at this point.
I got it. Sorry.
Can you pin us again, Cam?
Yes.
Might be over quickly anyway.
Do we have some signs of life?
Yes, we do. I hear it buzzing.
There we go. Okay, it's moving. It's not fast. The quickest.
Cautious spot.
Yeah. Oh, look, we're turning left. I think one of the wheels is slipping. Oh, it's not looking good.
Better catch it.
No. Let's see if it can spot a block at least. It's not gonna see that. Yeah, I like your moving camera because I very quickly noticed how narrow this range of
Yeah.
view is, and if you can't see it at all, then you're just blindly driving around. It doesn't know that it's there.
Doesn't seem interested.
Yeah, you can see that, right? See if we can at least get it to turn towards the block. That would be nice. There we
Maybe
go.
he's full.
You're about to go down there.
Thinking about it a little bit.
More. No, turn left.
You
I mean, I
got,
could review like
you got,
instruct-
you got to
Oh,
use the force more, Anthony. This is like that. This is like that Hello Robot demo. Come on, robot.
Well, you'll slip in or what?
Yeah.
Anyway, you guys get the
Anthony, we have all been there.
I was telling these guys before we started, I thought briefly about switching from a camera to like some kind of time of flight sensor that would just give me some depth to work with, because that would probably be easier than trying to figure it out like a camera. So that might be where I go with this. It's like I'm gonna have to try.
Keep talking. He's going to get a phase 2 here.
Well, it's gonna get it off the table, but the question is it gonna stop and avoid driving off the
Well,
edge?
if you switched it off, if you switched it off, he would.
I'm probably just gonna keep going straight.
Let's see if he stops. Let's see if he stops.
Get ready.
You might get a phase 4. All right.
All right. Anyway, thank you for your patience. I appreciate
Thank you,
it.
Anthony. That was awesome.
Thank you very
We were
much.
amused. We were entertained.
How long does it take it to make a decision on some action that it should take from the image?
I can run all, I think, 5 or 6 of the models that I have on there in about a second.
In a second? Okay.
And so one of them that takes like most of that time.
Okay.
The object detection takes a lot longer than the classification.
Okay.
Yeah, I can run like 5 classifiers like really, really fast.
Okay.
And then otherwise the whole loop would be a lot faster than figuring out where in the frame it needs to be turning and so forth. So thank you again.
Okay. Are there any other table bots before we move ahead? Let's shift into floor bots now. I've got a floor bot. It's part of the, let me share my screen. This is part of the Smarty line here. Dr. Bott, Ross, Bill McCurry, and Thomas Messerschmidt and I are writing a book called Mock Bots. It's basically mock turtlebot form factor. And we're building them with, here's Smarty 1 bot vec, here's Smarty 2 with a Create 3. This is Smarty 4, it's built from HackerBot. And this is my yet to be built Smarty 3. And this will be made from a Roomba. But anyways, I've got Smarty 2 here in the corner, and I shall attempt a double Floorbot Challenge Phase 1. Floorbot Challenge is basically Phase 1, go from one end of the room to the other. I'm going to do that twice. And so I'm going to do it with, this is the robot right here. This is Smarty 2. Built with a Create 3 DL06 LiDAR, Logitech webcam, and a HomeBrewed ultrasonic sensor. So I'm doing some waypoint following with Ross with RViz 2 here. We'll go there. We'll come back here. We'll go there. And we'll come back here. And I'll say, we'll end up in a lounge here. And then I'll just start waypoint following. There you see the global path planning lines. I'm going to help the robot along here a little bit. Now I've got my hacker bot parked in the corner there. I hope it doesn't make him delocalize. But here you see the Smarty 2 headed to the kitchen. And you'll see the ultrasonic cone pop up when he gets near an obstacle. That's I need to still write a plugin for the navigation stack so that that goes into the navigation algorithm so that it doesn't navigate under the bed and under the couch. Let's look at the nav stack right here. Okay, we got out of that. That went through some recovery behaviors, which include like pausing and backing up and spinning and stuff like that. Anyway, so here you can see that the robot's passing new path. There he's actually reached the goal, the first goal, that being to at the end of the hallway. So now he's coming back through. So he's going back. When he gets back to the end, that'll be a Floorbot Challenge Phase 1. I'm going to do something here if I can. Oh, okay. So this is, I've actually got my hacker bot over here. Let me drive him around and see if I can get these two to interact. That'll be kind of like some battle bots or something. So here's there's the hacker bot. I'm going to drive him forward. Okay. He's in the hallway here. This one, I've got a problem with my map, or I'd be autonomously navigating with him too. So here comes HackerBot. Here comes Smarty 4. I'm going to turn around here and see if he can spot him. Oh, there he is. He went around him. That's pretty cool. Let's see if I can spot him over here. Bear with me. So this is the hacker bot. This is the Smarty 4. He's going forward here. Let's see where. Okay, the other one's at the end of the kitchen, and the hacker bot's probably right about here. I'll go to his camera, and we'll go forward and turn. And I should see Smarty 4 coming around the corner. There he is. And he navigated around him. You catching this? So there goes Smarty 2 to the other end of the hallway. So he just drove by the Smarty 4 robot there. So yeah, like I say, I've got, you can actually create a map with the hacker bot, and I have been able to navigate with it. Right now, I've got trouble with its controller and communicating with it. So here, that's a Floorbot Challenge Phase 1 × 2, and he's headed into the lounge now. See if he can get over the extension cord. I got a situation here where I'm gonna run it on battery backup and everything. It's kind of an emergency situation, but it's okay. We'll make it. Let's see here. See if I can get that camera. Well, let's go backwards. Anyways, so that's Smarty 4, and this is Smarty 4. Let's see where he is. Bear with me. Here. This is 2 robots, so I do get 10 minutes. So I have had a camera with this guy, or I should say I have had he can make a map. He could drive around with the map. And this is the HackerBot group. These are mostly Arduino and AI guys. It's a great group. I'm gonna drive forward here. Electricity in my apartment's on revolt. Some of the outlets don't work. And my AC is off. I had to run jumper cords in here to get the, I thought I could do without the computer, but I realized that I needed to share my screen. But anyways, here comes the robot going around the corner. And if he turns, you should see Uh, anyways, the Smarty 4 is right there, and the room's too dark to see. But yeah, so this is the hacker bot. Let me put the hackerbot.co. And it's an interesting group. We meet every other Thursday. They've got an AI head with LLMs, and they've got an arm that can grab stuff. We're mapping and navigating, and it's a really interesting group. I'll put this link in the chat. All right. Are there other floor bots out there? Are there any other floor bots out there?
Hey, Camp, yeah, I got
Yep.
something.
All right, Dr. Bot, go ahead.
Okay, you seeing this?
Yes, we're seeing your screen.
Okay, I'll play it. I'm not sure if the audio will come through, but if the audio doesn't come through, I'll narrate over it. Are you hearing audio?
We're not hearing audio.
You're not hearing audio. Okay, that's what I was afraid of. So anyway, this is my this is Run What You've Run challenge, and this is a create 3 base mock turtle bot. I'm working this uh, camp. See, I'm hearing the audio, but you're not. So I'm just narrating it. So this is around. I have around $600, $700 in this. I can run it with a Logitech. It has an LG 19 LiDAR. I'm using something called laser filtering. So the legs don't show up because I have a filter. The guy has a superstructure. The LG is sort of off to the side. And if you zoom in, I can turn on that filtering or turn off the filtering. So it rotates. So again, the thing is, I've come up with the URDF for that. And, the key is that a full TurtleBot 4 standard is around $2,000, and I basically can build the equivalent from pieces parts for around 600.
Yeah, that filter is great because I have to go to like Colorpaint and erase all the artifacts from after I run Slam Toolbox.
Is there like an agreed upon like best like setup for like where you can block the LiDAR and not hurt your navigation performance too much, other than block as little as possible?
You've got robot radius and another variable for a rectangle that you can put into the navigation so that it ignores things that are within that space. And I could have sworn it had worked in Slam Toolbox, but it quit working. And I've gone back to just editing it out in a graphics program. But what Alan has here is a filter package that you run, and it does indeed filter it out when you're mapping. Is that answer your question?
It's called laser filters. It's a ROS package, and they have all different types of filters. One of them is called a footprint filter, which footprint does the footprint of the robot. For the create 3 TurtleBot, mock TurtleBot, I'm using something called a box filter, which is a little different. I actually just did a box around the robot, and they have all different they have like maybe 20 different types of filters you can put on. So my next video is I also have Ubiquity Robotics Magni robot that is a little bit different. It also is Pi 4 based, jazzy. It also has a sonar array on it. I haven't got that sonar array to work, but I'll get this going. So the Magni, Ubiquity Magni's been around for almost 10 years now, and they're basically more functional than Create 3 based because they can move around 100 to 200 pounds. So we've had this configured as a table bot. We call it a waiter bot. This guy also is working in RViz and filtering. The only issue I have with this guy is I haven't figured out how to display the sonar codes yet. I don't know why I can't get the, I'm getting sonar data, but I can't seem to display the cones. I'm getting some type of quality of service issue, or I can't map the actual position. This guy's also using the Raspberry Pi 2 camera, and that was a picture of my foot. See, this is a good thing. This is my desk, and you see the big bottle of antacid tablets that's next to the terminal, because that's what I actually had a rare event here. The rare event was I had all 3 robots working in the same week.
Alert the press.
Well, now the botvac is having an issue. The battery died on it, and I can't charge the battery. So my
Damn those Nito people.
yeah, just totally unreliable. QoS on that guy, especially their technicians are just
Yeah, they're technician, that one guy.
So I'll show my last. So that's the thing we had. Yeah. Let me have this one. So yeah, 3 working. See, I'm still behind you. You got 4 working robots. I only got
No. The Roomba one's just a shell. That's a to do. I'm gonna have it running in September though.
So again, these are all table bots. What else do you need? I had to figure out that weird table.
Correction, Alan. Those are not table bots. Those are smart tables.
Smart table.
They're floor bots.
Okay, and this one is up to where we're doing nav2 with it. And I was in this little video, I was giving it what you were doing before, doing a little go to goals, so we don't have to murder it over.
Hey, can we have a goal at some point of doing a table bot challenge on top of one of the smart tables?
Don't tempt us.
So
all right, thank you very much.
Yeah, you have any questions?
Yeah, let's get rolling. We got to keep going. We got a lot of demos. Ross, I know you're on the East Coast. You want to do yours? Are you still there, Ross?
Yeah, you caught me by surprise.
You want to go to somebody else and come back?
No, I wanted to. I want to bring up another picture, and I'll get going here. Just a second. I can't think and do it at the same time. 87591575859. Put somebody else in between, and I'll go after him.
Okay. Is there another floor bot out there by chance? Big Orange is a floor bot.
Yeah, Big Orange. I've
Look
got
for it,
a
Jim. You need to set up?
run what you brung floor bot.
Okay. Okay.
Yeah, it's the batteries is draining as we speak, so
You're on.
so what I've been working on is trying to do advanced sort of use AI to direct the robot, what the robot will sort of move in more complex and steps, say. For instance, I'm going to demo here. I'll demo it first. I want it to drive in the path of a square, and I'm using what's an AI model from OpenAI, and you should be able to see my screen now. You do.
Yes.
So
This is Slam Tech?
so this whole system is Slam Tech. Yeah, this is my Windows-based Slam Tech system, which has full mapping and does a lot of things that very well that for because of a commercial product base. This one is now deprecated, and I'm just riding it out until it breaks, I guess, because you can't really replace it. But unless
You're talking about the base?
yeah, the Slamware core, yeah,
Is
the
Slamware no more?
or Slam, they do have something new, but you have to spend a lot of money or buy many of them or some. I'm not sure. They don't really support the sort of hobbyist level thing for $500 anymore. So it's
You're
like
talking about DF Robot.
this is Slamtech, the Slamtech company itself.
Hmm.
So, but yeah, it's a good system, and if I get a chance to buy a backup, I might. But the firmware is now 2019 and aging, but it still does new things for me. I can still add new because it's a basic moving robot with navigation, so you can add high level concepts. So with that, let's try doing this. Hey, Orange. Drive in the path of a square of 1 meter sides. So here it's sending this info to a chat GPT essentially through this thing called LangGraph. And there you see those purple things are the square. And now I'll show you Big Orange on my video is moving. And on your screen, you should see it connecting the dots. So I did make a video of this just in case I couldn't get the live one, but looks like I've
Is this
prepared.
live?
This is live.
All right.
So I don't have a lot of room in this area, but I want to, it's much better to have more room. But so to give a little background, this system is called LangGraph, which is a relatively new AI tool or system, I should say, that can utilize large language models and with tool capability. So if you can see the text I'm showing here. Let me make it bigger. So if we go through what happened, I gave it a command, drive in the path of a square 1 meter sides. Then I basically my regular parser doesn't catch that with all the normal commands. So then it goes to the LangGraph system. And because it's looking for the word drive or move. And then I send this text to the large language model through LangGraph, the system called LangGraph, which has tool capability and memory and other things. And so then the AI simply writes up a plan. And the first thing it does is say, oh, well, I need to know where I am. So it calls the function getPose. So it gets the current location of the robot. And then then since I said go in a square, it came up with a set of coordinates based on the starting point and added 1 meter to each dimension or wherever to go in a square. And then at the end you see the assistant says the robot has moved on the path of a square with sides of 1 meter, starting and ending at the initial position. If you need any further assistance, feel free to let me know. So I wish I could, maybe another time I'll try to print out more of the sort of internal, if I can get it to print what its internal thoughts are. But essentially what it's doing is it's coming up, it knows all the tools I have. In this case, there's just like 2 tools, get pose and go through a path given the following XY locations. And I describe all that in the code in English, so it knows what each of these routines does, and that goes to the language model. So language model actually reads your comments or whatever in your functions, and so it knows what these functions do. And so they're annotated. So then when the model, when it comes up with a goal, then it can figure out what things to use. So for instance, if you see here this function, this particular function, or this particular uh, class here, move locations input, it says list a list of locations to visit in order. Each location, blah blah blah, has an X, Y, and then the desired. So all this English here is actually for the model for the AI to know what it has access to, and then it can create a plan to use those things. When you tell it go somewhere, it reads this and it says, oh, I can get the pose, the current location if I call this function. And if I want to move in a bunch of places, I can call this function. Here's the actual descriptions.
So
And
is that LangGraph doing that, or is it figured that out with what you've got?
yeah, well, so LangGraph has to come up with the AI model, actually the large language model has to come up with a plan, and then from your prompt saying drive in a square, and you could have said this, and I could just I can do a triangle now if you
All
want.
right. All right. Well, we need to move ahead because we've got a lot
Anyway,
more robots to go. But regardless, do you have a picture or a video there of Big Orange? I haven't seen Big Orange himself yet.
He was on my video just
Yeah, all we saw was the command center. All we saw was okay, there's Big Orange. All right.
oh, you saw this. I pointed the camera at him.
Oh, we were seeing your desktop.
We were watching the desktop.
Oh,
We were watching the visualizer.
oh well,
Jim?
here, instead of doing it again, I can just show you I can play some of the video here. So this is what right, yeah. How do we get out of this screen?
How is it measuring that distance as it's moving the 1 meter?
Well, the robot knows already how to do, this robot already has a map and everything, and
Got odometry.
it's got odometry that, I mean, Big Orange can navigate based on its map, right? Here's the map. Are you seeing this? You should be able
This
to
is what we
see.
were watching, Jim. We were watching the map. Yeah.
Right. Okay, but here's the actual robot moving. You see, the robot, I mean, the map is here, right? And it has LiDAR, and it has odometry and a map, and it, just like the raw system, it knows how to go anywhere you tell it to based on odometry and or LiDAR, right? And so when you tell it to go in the square, it makes these 4 waypoints, and then and then it executes the waypoints.
All right, that's what I wanted to see right there.
Yeah, here, this is what it just did. I tried to
All right, all
move
right.
my camera over to my
No, that's fine.
video, but yeah, you can't really look at both at the
No,
same.
that's awesome. Big orange, ladies and gentlemen.
So yeah, this is the beginning of being able to do advanced or complex behaviors and that are take multiple steps and using an AI in order to create those steps for
I
you.
like that base.
Yeah, so that's
All right.
back into.
Thank you, Jim. Thank you very
upgraded.
much.
Thank you.
Ross, are you ready?
Yes, sure am.
Model.
So I
You're
should be
on.
sharing.
Set.
There we are. Welcome to Ross's Robot Garage.
Poster?
This
That's
is
awesome.
this is my current collection of robots that are in various good to not to good ability to move. So just to give a quick tour of it all, over here is my original. That's an original TurtleBot. I purchased it when Willow Garage first came out with it in 2010. It used a Ross 1 Diamond, which I think was 12. Right now, it is my contribution to the book that Cam's book that he's mentioned already, the mock
Our
book. This is Turtletron. It uses the Create base down here that has a driver that was developed by Autonomy Labs up in British Columbia and modified and made much more sophisticated by Sergey, much to my gratitude.
Hey, Sergey.
It uses now. When I first started this a couple of years ago, I had a Raspberry Pi 4 Humboldt. It's now got a Raspberry Pi 5 that's equipped with or configured with Jazzy. LiDAR here, LD LiDAR, and a OAK camera underneath here. And I have the version that has the IMU in it. I'm only using the camera for RGB, although I'm going to wire in, coding wise, the ability to perhaps convert the depth field to a scan to supplement the scan from the LiDAR. Okay, so that's the TurtleBot. It sort of runs, but it sort of doesn't. Okay, let's see. What do we go to? Yeah. So let's move on to the robot of this collection that works the best, and this is the BotVac that is using the code developed by Jim Nugent a couple of years ago, and
Mike Ferguson.
And
Mike Ferguson wrote the original Nito node. Right.
It has, of course, this is a Raspberry. What's in here? This is a 3 in the dustbin, and it's fun to entertain and neighbors and friends that want to find out what I actually do in the basement. Very, very, and it's actually it's probably the least expensive way to have a navigating Ross robots. Cool. So here in front is for completely different. This is a pair of Sumo bots, which are commercial packaged by Palulu. But this is great to get my 4-year-old grandkids and his friends interested in robots, and the two of them run around on a circular platform and chase each other and chase blocks. So that's I've very successfully used these in various demos at libraries and things where the purpose is to get kids interested in robots. They just love these things. Okay, moving along. This is probably the most sophisticated of what I have. This is a TurtleBot 3 from Robotics. It's now 8 years old. It was originally came with Noetic, and I have just finished changing out the come on, Ross, where the heck is it? There's a Raspberry Pi in here. There it is. A Raspberry Pi. Put it in the camera here. Raspberry Pi that's now has Jazzy. The camera works with much gratitude to Alan and other folks who have been working on getting Camera Ross to work well, and it does. Indeed, it does that.
Marco, you gotta say thanks to Marco.
And Marco, gotta thank Marco. That's for sure. The cool thing about this is that the original Noetic code or code that was provided with it and uses the camera to identify the edges of a track, and I'm going to adapt that code actually with some help from Robotics themselves, who are trickling out a Jazzy version of the code where the camera identifies a yellow and a red side of a track, and it will navigate around actually they refer to it as auto race. The robot can race around it, and I'm just currently calibrating the camera, which is I actually got it to calibrate in Jazzy. Anyway, so that's a TurtleBot. TurtleBot 3 has a LiDAR, of course. It has its own motor driver. There's a motor driver in here that runs these digital servos. It's a really nice, sturdy unit. And I'm going to finish off with the latest manifestation of robots. This is my RacerBot. It started off. It's actually a evolution of a robot that I built, or following the instructions from NVIDIA, which the tech and what was it called? JetBot, whatever the controller was. Yeah, it's actually a donkey car platform that originally had a Justin Nano in it. It uses the RC-esque to run the wheels, and a servo for steering. Okay, so it now has a Raspberry Pi here that's loaded with Jazzy right now. Uses Pico here that I must have spent several hours trying to get it to code using Platform IO, which which I was not able to do this afternoon, but work on it. The battery fits under here. There's an LD19 label on top. The code is based on it's basically a Lena Robot 2 code with scripts for driving the ESC from Jim Denuzio, and quite a significant upgrade to Jazzy and rolling, which I've decided exactly which path I'm going to follow, but there's an I know there's some controversy with that. There's a developer called Hippo 5329 who I don't think those numbers are right. Anyways, he has a he has a repository that I'm actually following, and we'll see how far I get with that. So there we are, RacerBot. Ta-da!
Thank you very
Ross's
much.
Robot Garage.
That's awesome. And you got a lot of robots there. How many robots is that? 1, 2, 3, 4, 5, or 6?
Yeah.
You
Yeah,
might think
that's right.
you might think you're obsessed with this stuff.
Yeah, that's right. Actually, I guess I have to show you one more that cropped up. Is that there's a developer called KAIAA who published this called a MakerBot Pet. He sells the platform using
Is
the
this new?
SP32. Pardon me?
Is it new?
Yes. Yeah, I put this together just over the last month or so, on a base that I had an old Arduino, that was sort of working, but it now has an ESP. It runs Jazzy, and it runs Jazzy, the Ross Jazzy.
Are you calling that MakerBot Pet?
Let's see, it's called Maker Pet. Maker Pet is the his
Yeah, I've seen this. This seems to be getting some. This is becoming popular. Yeah, this seems to be gaining some traction.
it's kind of cool. It has a LiDAR on top. There's he's got code in the ESP32, micro Ross code, and provides the desktop.
I just put a link in. I just put the link in the chat.
Anyway, it's a pretty. It's come together quite quickly actually, and
yeah,
the desktop package is actually available as a Docker, and so literally within 30 minutes or so.
Don't tell us it's easy. Don't tell us it's easy.
Easier than if you had to load in all the desktop code yourself, but
easy for you maybe.
Yeah, not so.
Anyway,
right, that was kind of cool. So
thank you very
there's
much, Ross. We got to keep rolling here.
Number 5. All right,
thank you very much.
I'm going to head off. This is getting late here.
It's getting late there in Canada. All right, buddy.
Thank you. We'll see you all.
Right.
And congratulations. Congratulations to the Florida Panthers for winning the Stanley Cup.
I knew you'd like that. All right. Thank you, guys. All right. Who's next? Stop. Yeah, there we go. Who's next?
I gotta run what you brung, but
all right, go for it.
All right, let me power it up here. All right, so hold on. Where the battery's going. There we go. Wait, not incinerate this. Wait, okay. So all right, so just pair this to my computer here real quick. All right.
This is Ross at the Maker Nexus, isn't it? I meant to say this is Nathan.
Nathan, yeah. All right, cool.
Okay, I'm not seeing you at the Maker Nexus.
Okay, yeah, sorry. I was just kidding. All right,
there
so
you
next, move the table. Hold on.
Hey, Orange.
Okay. All right. So this is a balancing robot that I have been, or let me do camera. All right. So this is a balancing robot that I've been working on. I believe the last meeting I brought it, I just had it standing upright, and now I have it fully remote controllable. And also, if it falls over,
you can get a TableBot challenge going back and forth. There's ain't nothing says it can't be remote controlled.
Trust it. I don't trust it. So, all right. So I have it if it falls over, turn off. So if you
come on, Nathan.
Okay, fine. I'll put it on the table. Oh, okay.
Let's see now. Now you got to get close.
Gotta get close. All right.
Spotter.
Spotter. All right. Spotter. All right. So
I've done this many times.
all right. So it does have, well, I mean, gyro stabilized, obviously it's a balancing robot, but it does do yaw hold. So if I pick it up and turn it around, it'll go back to where it was. So you can spin it, you can drive it around.
How does it know its original position?
There's it's original, so it translation wise it doesn't, but it does have a 3-axis gyroscope and 3-axis accelerometer, so it can tell its rotation.
This looks kind of like the Hello Robot demo.
Tony hasn't had to catch it yet, so.
Nope.
But he looks like the guy that was demoing the Hello Robot. He was going through all kinds of demos.
Guardrailing up the robot, yeah. But it does just hold itself up now. It is actually controllable. It can.
Hey, you got a phase 1 there. That's good enough.
It's under remote control though. It's not doing its own thing.
I'm fine. There's
Okay.
nothing in the TableBot challenge that says you can't do remote. It's cheesy, you know, but there's nothing that says you can't do remote control. All right.
Yeah. But all right, yeah. So I was just finally figured out how to get it to drive around was the thing.
Thank you very much. Are there any more demos?
If I give it no input, like Tony, you can stand back. It'll just.
Arma.
Yeah, it'll just hang out there. It'll just.
Okay, cool, got it.
And if if I were to pick it up and go over there, it will try to spin back around. It does drift a little bit, because the problem is there's like backlash on the motors because they are like just cheap gear motors. So it jitters back and forth trying to hold itself up because when the motors reverse, to try to compensate the other way, it has to slam the drivetrain around a little bit. But so it does accumulate error on the position. Realistically, I should be tracking like the overall position rather than just the difference in ticks at every step. But I mean, right now I was having trouble tuning the PID loop for like a position lock because I mean these balancers have kind of like counterintuitive behavior. If you want to go one direction, you need to lean the robot in that direction. But in order to lean the robot in that direction, you have to turn the wheels in the opposite direction of the way you want to go. And then this is a little bit of a lag where you kick yourself out of balance and then you can start driving the way that you want to go. So the PID controller was not happy about that.
Can you add a little bit of like tolerance and delay so that it's not shaking?
It's just a tuning thing. Yes, it's a tuning thing. This is the first of these I've ever built. So
yeah.
So I got like a lot of this way, but like the problem I had was when it's balancing, it would start to go in one direction, and it like it's not aware that it's transferring. You know what I mean?
Right.
Like it doesn't know that it's moving laterally, even though it's trying to keep the it would just keep speeding up and speeding up and speeding up. Speeding up and
yeah.
Like so, how do you solve?
Well, so I solved that by there are encoders on the wheels, so there are encoders on it, so it knows it is moving. So there is a loop that if it starts to move out of its initial position, it will try to tilt back towards the direction that it started from. Yeah, so so basically there's two cascaded PID loops. There's one that holds a desired orientation angle, and then there's one that tries to hold a desired position.
Before you start to get into your multiple PID loop explanation, we need to keep moving, guys. Thank you very much, Nathan. You may want to pick that up on no, it's fine, it's fine, it's fine. You may want to pick that up on the mailing list and who's next?
Across the room.
Who's next? Who's next?
The tell is too much.
Who's next with a demo?
Get it up right.
Who's next with a demo?
I was being brave because technically that gamepad was running over the Wi-Fi.
Don't make me do another demo. Who's next?
I've got a demo, Cam.
Go for it. Go for it, Thomas.
All right. Let me share my screen. Now, this doesn't include a robot, and I'll make some excuses here because, well, nobody else will. So.
Hey, it's AI. That's robotics.
That's right. This is just some research I was doing, and I'm going to share my screen. Give me a second, and I'll walk you through something that you might find interesting. At least I did.
We're easily amused.
I'm trying. So the question is, can we pick up a bottle of beer without any sort of sensors other than a camera and a large language model. And this large language model, as you can see, is ChatGPT 4o for Omni. And I started uploading pictures. Now I can do this programmatically. I can do it one at a time, but I wanted to do a proof of concept to see if it could handle this, if it could do what I wanted it to do. So you can feed it pictures through the program, through the API, or through the app. This is through the app. I'm not hiding anything here. And I say, well, what do you see? And it says, I see a cardboard box. And inside the cardboard box, there's a small glass bottle of Coronita Extra. And a metal grabbing tool. And that's what it was. That's one of those pickup tools for those of us who have bad backs who don't like to bend over so much. So I was going to use that as the end effector and simulate a robot. And it says right there, the scene appears to be a control setup, possibly for a robotics or vision experiment. I said, yeah, you're right. Trying to pick up the beer in the photo. Which way should I move my tool? It said forward and slightly right. And it says the grabber is too far back, blah, 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 and I moved it. And then I said, now it says move slightly to the right and move forward. Then you can lower the tool. Well, there's a problem right there. I can't get much lower than that. It says you're almost there. The alignment looks good horizontally. Okay, not really. We'll move on. And I stopped right there. It was a problem. So I tried again. If at first you don't succeed, waste some more time.
We are figuring this out as we go along.
Yes. So I said to myself, well, what's missing? I said, I know what's missing. An overlay with left and right listed on it. So we could tell left from right, top from bottom, which area of the screen it's in. So I created that. And then I took the photos using the overlay. Of course, I say, what do you see? You're viewing a labeled camera feed of a cardboard box set up, divided into a 5x5 grid. Was that a 5x5 grid?
Yes.
It's a 4x5.
Oh, 5x4. It hallucinated.
It did. Set up is marked left on the left side and right on the right side. At least it got that right. And it mentioned the beer bottle visible in cell 9. Is it available? Is it there in cell 9? Actually, it's mostly in cell 8. I'm not sure if it's in cell 9. Let's take a look. Nope, not in cell 9.
It's close to 9 though.
It was close to 9. So I went on. I said, I'm wanting to grab the bottle. Okay. The bottle is centered in grid 9, actually grid 8, slightly toward the back wall. Is it toward the back wall? Yes, it's slightly towards the back wall. You got that right? And so it starts giving me instructions. Move right, about 2 to 2.5 grid units, move backwards. And I had a little problem with it. It kept telling me to move backwards. What I eventually got was backwards didn't mean towards the camera, backwards meant towards the back of the box. Here we say the gripper is now centered at the base of the bottle in an ideal position to grab it. Well, is it? Okay, we'll try that again.
You
Well,
got
it
1
is.
minute, Thomas.
All right, thank you. We'll run through this. It says you're perfectly aligned now. And I say, you missed. And after a while, I figured out that it wanted me to go towards the back of the box when it said back, not towards the camera. When you say back, do you mean closer to the back of the box? It says yes. So where should I move now? And it told me, and it told me, and it said, go ahead and close the gripper. At that point, I did have the bottle inside the gripper properly, and I lifted it up.
Wow.
The conclusion is, does it work? Yeah, kind of, almost. Will it be more successful than anybody else trying to pick up a bottle and winning that old get me the beer contest? I don't know. I'll let you know after I put the robot together.
This is with a regular camera and ChatGPT 4.0.
That's all.
That's very powerful. That's like spatial intelligence stuff.
It's
Yeah.
moving forward. That's the point of this demo.
Now, Thomas, why do you take the text that you're receiving back from the chat and convert that into motion on a machine?
I'll do that. That's phase 2 of this project.
So you have to be able to reinterpret what it says and then convert that into whatever servo or tire movements or
We'll expect to see that. We'll expect to see that in September, Thomas.
I'll do my best. That's my goal.
I'm thinking
Thank you very
August,
much.
August,
Thomas Messerschmidt, ladies and gentlemen. All right, who's
Yay.
next?
So
Who's next? Any more demos this evening?
not exactly a demo. It's more of a thing in progress.
Turn
All
off
right.
screen sharing, Thomas.
That up a little bit.
Works in progress are good for partial credit.
Okay.
Thomas.
Yeah, I'm trying
Stop.
to get the screen sharing off. Let me figure out how to do
Thank
that.
you. No problem.
There we go.
Your discretion is advised. Cheesy jokes.
Ralph Campbell, ladies and gentlemen.
So this is Metacat. I showed it a couple sessions
That was
ago.
last month.
And I've since skinned the cat. It's now literally a rag doll. And
Oh God.
Not creepy at all.
no danger of uncanny valley there.
You know, I have a picture. Somebody actually brought an animated cat skull with body, and but it wasn't their cat. It was some cat they found. Anyways, go ahead.
They found it.
So I can see from trying to disassemble this, it must have been hand assembled because the fur is glued onto the body, and the servo for the tail was clearly connected after like inserting the body into the outer fur, and then there's fishing line. The tail works pretty much as I would have expected. It's got fishing line going through segmented discs with the holes, and then a piece on the end. And so when you pull on the line, it moves in that direction. And so the fishing line went through the holes in the back, and this little plastic end screws on and holds it in place. And there's a servo inside there, which looks to be like a fairly normal hobby servo, except that it's got 4 wires. The 4th wire, I think, is the analog voltage position. So you can get feedback as to its current position.
Well, it means the control, the angular control's not inside the servo itself.
It's just feedback. It's just like a resistor pot, you know, so you get some positional signal. And likewise for the head here, it's got 2 servos in an XY thing. These are touch sensors on the head and the front, and there's another one that went over the back. There's can't really see it, but there's a little condenser microphone in the center, and there's a speaker in the bottom, and an ESP32 that runs everything, and a couple of 18650s or whatever they are.
That's an ESP32, and I wouldn't say this is so much of a consumer product. It's kind of specialty, but I mean, using an ESP32 in that type of product, isn't that that common, would you think?
Yeah, it's becoming more and more common. Yeah.
Yeah, it's inexpensive. It could potentially have Wi-Fi, but I don't think it does. It does have a little port, which I assume is probably USB connection.
Ralph,
Yeah.
there's the one that the young lady presented. I think it's about 10 years ago. Not creepy at all, huh?
Creepy at all.
Yeah, the ESP32s, like if you're looking to do your own design with them, if you buy in bulk, you can get the whole module for like $1.50, like in like 100 unit like increment. So like you can just be able to do a product where like your entire radio solution and microcontroller.
Is that ARM architecture? I should know this.
Oh, well, actually, so it's either the newer ones use RISC-V, the older ones use something called Tensilica.
RISC-V, really?
The new ESP32s are mostly RISC-V. Some of them are still, it's called a Tensilica LX7. It's some kind of DSP architecture.
So
yeah, Tensilica was MIPS based, but it had tools to let you extend the instruction set and add specialized coprocessors and things. Without having to, and so like the compiler instructions would then be generated to update your compiler and everything. So they all kind of work together. Yeah.
So where are you going with this Metacat, Ralph?
So the idea so number one, I was curious how it was built. And number two, the next step would be to like learn KiCad and FreeCAD and your 3D modeling tools and 3D print something that could be either reuse the fur because obviously I don't know in the ESP32 I have no way of really rewriting things or complete or
Did
uh, sure. So it's I don't know. We'll see.
It didn't actuate legs at all. No leg attachment.
No, there's no leg attachments. These are just padded, stuffed.
Needs wheels.
Needs wheels. So it's just kind of a puppet net right now.
Legs, go for legs.
Thank you very much.
You gotta take
It's pretty big silent.
You just
sort of a fun project. It's you know, to
That's awesome. If you can't open it, you don't own it, right?
provide, I wanted to have 2-axis tail movement, so, but I could reuse the discs. They look like they were easily designed to have an extra set of holes. So you could do, you know, up, down, left, right. Tail movement. But then you'd have to figure out kind of exactly how to position the servos and the drive wheel.
Build the body from scratch and add the fur to it.
If you could, if you could measure the, you know, get all the measurements of that.
Right.
And then we could create our own, you know, 3D model that matches it.
Exactly.
And then we'll be compatible with the fur skin.
Exactly. Exactly. I mean,
thank you very much, Ralph. That's awesome.
Yeah. Sure.
Look forward to the progress in September. Metacat.
Yes, well, it may be a while before it gets much beyond being disassembled.
I think what you're working on is Metacat.
Yes, exactly.
I'm sure something will evolve from it. Who's
But I knew-
next?
Yes.
Who's next? Any more demos this evening? Looks like Stephen Nelson may be frozen there. All right. Well, I want to thank everybody for showing up, and especially those who have participated. This is a lot of fun. We'll do it again in September. I make a motion the meeting be adjourned. Do I have a second?
Second. Seconded.
All in favor say aye. Aye.
Aye.
Those opposed say nay. Ayes have it. Meeting adjourned. Thank you very much. This was awesome. Keep building them homebrewed robots.
All right.